Periodic table, atomic structure, and compounds. The periodic table. Different atoms have different numbers of protons and electrons, accounting for all the differences in the physical properties of matter. Different types of atoms are called elements, and there are around 118 known elements. Each element is made of unique atoms. An element is one type of atom, and the periodic table is a table of all the elements. All of these elements are presented in a chart called the periodic table, which lists and organizes every element in boxes. Each element is assigned a chemical symbol, which is 1 or 2 letters. The first letter is uppercase, while the second letter, if there is a second letter, is lowercase. For example, oxygen is represented as O, while zinc is represented as ZN. A chemical symbol is 1 or 2 letters that represent an element. Each square has information about the element. The top number is the atomic number, and the bottom one is its atomic mass. The atomic number is the number of protons an atom contains. Elements are differentiated by their atomic numbers because each element has a different number of protons, and the atomic number is also the number of electrons. An atomic mass is the average mass of a typical atom of that element. The periodic table is organized by row and column. Each horizontal row is called a period, while each vertical column is called a group or a family. The elements are arranged in the order of their atomic numbers, so as you go across, each element has one more electron and has one more proton. Hydrogen has 1, helium has 2, and so on. Elements in the same group or column share similar chemical and physical properties. A period is a row of elements across the periodic table. A group or family are a column of elements in the periodic table. Groups of elements have similar physical and chemical properties. To remember that a period is across while a group is down, think a period goes at the end of a sentence, and a sentence goes across a page. Whoa. That just got wild. They really wanted to fly through those pages. Oh, here's some examples of what the periodic table looks like. Groups go up and down, periods go across. You'll probably see your element on here. Here we go. Atomic structure and energy levels. The nucleus of an atom contains the positively charged protons, neutral neutrons, and a negatively charged electron cloud, which contains electrons and surrounds the nucleus. Electrons orbit the nucleus at really high speeds. Because electrons are constantly moving, it's hard to say exactly where an electron is at any moment in time, but scientists can predict the probability of finding an electron in certain zones. Most of these zones are shaped like the rings around the nucleus because the electrons orbit the nucleus. Each of these rings is called an energy level. The lowest energy levels are the rings closest to the nucleus, and the higher energy levels are farther from the nucleus. Since electrons are attracted to the nucleus, remember that positive and negative forces attract. The electrons closest to the nucleus are hardest to remove. The energy level closest to the nucleus can hold up to 2 electrons. The energy level beyond that can hold up to 8 electrons. For example, the first level of an oxygen atom has 2 electrons, and the second has 6 electrons. Dmitry Ivanovich Mendeleev was a Russian scientist who invented the periodic table in 1869. Isotopes. While atoms of the same element have the same number of protons, the number of neutrons can vary. More neutrons means the atom is heavier. Atoms of the same element that have a different number of neutrons are called isotopes. The atomic mass is actually the average weight of the isotopes of a single element. Isotopes are atoms of the same element that have a different number of neutrons. Neutral elements and ions. The number of protons in a neutral element is equal to the number of electrons. The positives balance out the negatives to make the element neutral. All atoms at first have a neutral charge. Therefore, if you know the atomic number of an element, you know the element's number of protons as well as the electrons. You can also figure out how many neutrons are in the atom by subtracting the atomic number from the atomic mass. So, for example, here, the atomic number is 3. The average atomic mass is 6.941. So we say that 6.941 is about 7. We're rounding this to the nearest whole number. 7 minus 3 is 4. We're subtracting the atomic number and the atomic mass. Lithium, therefore, has 4 neutrons. Atomic mass minus atomic number equals number of neutrons. If we round the average mass to 7, we know that there must be a total of 7 neutrons and protons combined. Because from reading the atomic number, that there are 3 protons. We know that there must be 4 neutrons. From all this information, we can draw a model of the atom like this. We got our protons, we got our neutrons, and we got our electrons. If an atom has a charge, it's called an ion, and it has either more or fewer electrons than protons. If an atom is negatively charged, it has more electrons, fewer protons. If it's positively charged, it has more protons or fewer electrons. Molecules and compounds. When two or more atoms combine, they form molecules. Molecules frequently combine with other molecules to form molecular compounds. The simplest molecular compound has two atoms and is called a diatomic molecule. The prefix di means two. Nitrogen and oxygen are frequently found as diatomic molecules, N2 and O2. We can use simple models like these to represent the atomic composition of different molecules, or we can get fancy with computer-generated 3D models. So here's some examples of these models. Compounds have different properties from those that individual elements have on their own. Water wouldn't seem anything like water if it were a bunch of separate hydrogen and oxygen atoms. Why atoms form compounds? Atoms always want to be in a stable state. Many atoms find stability by combining with other atoms. That means giving away, taking, or even sharing electrons with other atoms. Electrons move in all directions, but they are limited to different electron shells around the nucleus. When electrons from the different atomic atoms pair up, they form a chemical bond. This chemical bond is the force that holds atoms together. Only electrons in the outer rings, or valence shells, form bonds. The valence electrons are the first to interact and decide how an atom will react in a chemical reaction. So notice how each shell here is numbered. Oxygen has 8 electrons, so 2 go in the first, and then we have 6 in the second, which are our valence electrons. How to write a chemical formula. Each compound contains a specific ratio of elements. A chemical formula is sort of like the compound's recipe. It describes the ingredients and their quantities. In a chemical formula, each element is written using its chemical symbol, which is a 1 or 2 letter symbol with a subscript beneath the symbol defining the number of atoms. For example, sugar contains 12 carbon, 22 hydrogen, and 11 oxygen atoms. So the chemical formula is C12, H22, and O11. There you go.